And g is a function that goes from here to here. Okay, g is the function that takes natural numbers into integers. Okay, so let's just list our natural numbers. So what have we got? Maybe we have our natural numbers. We have 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Okay, let's just consider them as our natural numbers, and let's see where they're mapped to. Okay, well let's think about this here. Okay, so when x is 1, okay, so when x is equal to 1, okay, we have g of x is equal to 9 times 1 plus 5. Okay, so g of x is equal to 9 times 1 plus 5, which gives us it's equal to 9 plus 5, which is equal to, it's equal to 14. So we know that 1 is taken to 14. So 1 is taken to 14. Okay. What about when x is 2? When x is 2, we end up with g of 2. I should have set up here g of 1. G of 2 is equal to 9 times 2 plus 5. Okay, that's equal to 18 plus 5. Okay, which gives a value of 23. So 2 is taken to 23. What about when x is 3? When x is 3, we have g of 3, okay, is equal to 9 times 3 plus 5. Well, 3 nines is 27, so that's 27 plus 5 gives us a value of 32. So 3 is taken to 32. Okay. And hopefully we can actually see what's happening, yeah? Is that as the values are increasing, as we're going through the natural numbers, okay, the values are increasing, they're being mapped into values that are also increasing on the side of the integers, okay? So we know that the integers, yeah, contain the values also 13, also contains the value 12 and 11, and so on and so forth. Okay? So the question is this a surjective map? Well, for it to be surjective, every value inside the codomain, every value in here, okay, every value would have to have an arrow coming into it, yeah? And we can clearly see that there's lots of values. Well, there's all the values that are less than 14, okay? So let's say for each, no, let me just actually say, for each x is less than 14, okay? For each x is less than 14, where x is an element of the integers, okay? So for every x less than 14, okay, and x is an element of the integers, okay? We have there doesn't exist, okay? There doesn't exist a natural number, okay? There doesn't exist an x in the naturals, okay? Such that I suppose that g of x, okay, g of x, okay, is an element of it's an element of this particular set here. Yes, that's actually not true. So there's lots of values. There's lots of values in the integers here. Okay, there's lots of values in the integers here. Okay. There's lots of values in these particular integers. I should say this is x1. Okay, let's say for each and every x1. Okay, that's in this particular set. There doesn't exist an x, let's say 2 in the naturals. Okay, such that g of x2 is equal to x1. Okay. So there's lots of values here that aren't mapped into. So this function is not surjective. It is not surjective. Okay, so this is not, it's not surjective. Okay. One way to think about surjective functions is by looking at the image. Okay, is to look at the image that's associated with your particular function. Okay, don't forget the image is the same as the range. Yeah. Okay, so the image is the same as the range. Okay, so let's say given a function, okay, f that maps a set A into a set B, okay, given a function f that maps a set A into a set B, okay, we say that f is surjective. This is another way we could sort of define it. Yeah, that f is surjective. Okay, well, it's going to be surjective if the image of f is actually equal to the set B. Okay? Really what I'm saying here is that the range of the function is equal to the set B, yeah? Or the range of the function is equal to the codomain, yeah? That's important. That's another way to actually define that, okay? In other words, we're really saying that every value that's mapped from here and where they're mapped into, that these values that are mapped into must be the full set, which must be the actual codomain. Okay. In other words, what we're saying is that the range is actually equal to the codomain, if that makes sense. Okay. Like, I mean, we can continue and we can keep generating functions, yeah, and we can keep testing to see whether they're surjective or not. Okay, but I think what this does is, I think we've done only a small number of functions here. Okay, but I think we sort of get the idea. Yeah, is that it's quite easy to actually, well, sometimes it's actually quite hard, yeah, okay, but in this particular case it was actually quite easy to try to figure out whether a function was surjective or not by just we look at the codomain and we ask ourselves, does every value in the codomain have an arrow going into it? If it does, it's surjective. If it's not surjective, if that makes sense. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this short video dealing with surjective functions, I hope that it was intuitive, and more importantly, I actually hope that was helpful for you, and thank you for watching. Okay, bye bye.